Welcome to Aquatics Live YouTube channel.
Hello guys, hi. Let's get started on the reassembly process. Well, prepping to reassemble, we'll say. The issues that I found during the disassembly process, I'm going to try to correct them before I reassemble the motor. One of the bigger issues that I found was that the crankcase has a gap in it. It moves around when you shift it back and forth. I don't know if you can see, but essentially the two halves, when you rock them, when you try to move it around, it rocks back and forth, and there's a crack in there when it shifted. Okay, so I don't know if you could see that too well, but just trust me, it's not good. Now, interesting situation with two strokes is that the crankcase is part of the process for combustion. I will try to explain that a little bit real quick here, kind of give you a quick demonstration. This is the cylinder. Here's the piston. We'll put it in here. The little arrow points the flow of the direction of gases. So we'll put the little arrow in there. That's the exhaust side. So in a two-stroke, we're at top dead center right now. The air comes in through the intake here, and it goes into the back side of the piston through the intake port. Then the piston starts going down towards bottom dead center, and at that point in time, the intake gases are being compressed. Those gases will keep compressing, and then there's two slots on the sides in here that are called the transfer slots. At that time, the air from the crankcase will get drawn through those slots to the top side of the piston, and then it starts going back up like a standard, like how a four-stroke works, and we get compression and explosion, and then it comes back down and comes out the exhaust, which is over here. So that's just a quick process of that. I know it's not the same as like a four-stroke motor, so it's a little bit hard to understand, and everything is done with ports inside of this cylinder here. You have an intake port, an exhaust port, and two transfer slots that bring the gases from the crankcase into the piston here, into the cylinder here. So this area inside of here is very crucial. Part of the time it's under vacuum, and then it's under pressure, it gets compressed, and then it gets blown into the cylinder. If any time in there it leaks, you're going to lose your compression in the top half. You're going to lose air. And you probably won't even notice it because there's nothing in here but air. It's just the mixture of fuel, which has oil mixed into it, and air in here. So it's not like it's going to come leaking out of these seams on here for you to know that it's leaking. In fact, this one's a black painted one, so if there was some seepage, I probably won't even notice it. So I'm pretty picky about that. All right, so to fix that, I'm going to surface all of these mating areas here. In fact, I'm going to do that on all the little covers here as well, just because. We also have, there's where the head goes. I'm going to very lightly surface this, just enough to get the paint off of here and make this flat. I do not want to remove any actual serious material on this. because it will affect the compression, and I don't want to do that until I'm ready to do the porting and check the squish gap and check the compression of it. I just want to get it put together and be stock as possible, and then I'll pull the head and cylinder off, and that's when I'm going to make the adjustments there. Another thing coming up in the plans here is this crankcase here. We have, this is where the crank goes, and then over here, this is where the clutch spring goes, and this is used as a drive shaft as well. It's the driven shaft, we'll say. The motor rotates, the gear, there's a gear right here. That gear drives this gear. Oh, and then it comes through out this side. And actually, I got this in backwards. Comes out this side, and then our sprocket to the rear wheel is right on here. Now, the bearings that we're putting into here, inside the case, we're taking the one seal off for the crankcase ones, and the lubrication from the two-stroke oil will keep these lubricated. Of course, I'm going to grease them before I put them in here, but we just want to get, that's how that works. Now, the ones that work for the this clutch shaft assembly in here, the plan is, or the plan was, to put bearings in there that are sealed on both sides. So yeah, like one of these, how it's sealed on both sides. Now, my thought on that is that those bearings there may have problems. They might get hot. To reduce that issue, I want to see if I can utilize this open area inside of here, since the shaft just goes in there and there's the spring here, and that's in there, but there's nothing in that open area. So if I take the shield off of the bearing, so I leave them unshielded and face that into that area, we could potentially put some kind of lubrication in there for the bearings to sit in. Now, they don't need to have a ton of oil in there. In fact, what I'm going to use is crankcase or gear lube in there, so like 90 weight. And but I'm only going to put like 50 milliliters in there, so just enough where the very bottom of this bearing has some gear lube on it. I don't want it sitting where this is floating in gear lube and that there's some extra restriction caused by this rotating in that gear lube. I just want so that barely this edge of this will be in there. Since the bearing is larger than this spring, I just don't want this spring to get really into the gear lube at all. In fact, the bicycle, when you're tipping back and forth, it's going to bring that gear lube one way or the other way, and we can probably have a very small amount in there and still for that idea to work. Okay, so now I'm going to show you how I'm going to surface these areas. Well, first I'm going to show you how I'm going to clean up the inside of the crankcase here. I did a little bit already, just trying this out beforehand, but got to wear safety glasses here and wear a face mask. But just for the demonstration, so I can talk to you while I'm doing it, I'm going to leave the face mask off for a couple seconds while I'm showing you how this works. So I'm going to use it's a die grinder. I can go really slow with it. I like that. Not like a Dremel where it has my Dremel, like when you turn down the speed on it, it doesn't like to start up or maintain it. So this is another way about it. I like this. This is a paint stripper wheel. it's pretty aggressive. Um, and with this aluminum, it's pretty much a grinder, but it won't take off too much aluminum at a time. I'm just going to kind of show you a little bit area here. I'm going to go in here and just kind of grind on this a tiny bit just to show you how that works. So clean this off on this edge here. It works really well. I need to be very careful that I don't mess up this. So I already see that I touched it there. So I'm going to be very careful that I don't let this get in here and grind this down. Now for the surfacing aspect of it, I'll show you a quick demonstration of that. I have a piece of glass here. This is an aquarium piece of glass. It's not going to break on me or anything. That's why I'm using it. I just taped the sandpaper. I'm using 400 grit. It doesn't need to be super fine or anything like that. But it needs to be fine enough that I'm not taking down any major material. Put a little bit of water on there, rub it into the sandpaper, get it nice and smoothed out. And then like on this cylinder here, so we got some paint on there and stuff. And when we're doing these, we want to bring it down on the sandpaper here. And we're going to bring it in strokes here. So we'll go down, and then we're going to rotate it a quarter turn, and then we'll bring it up. And then we'll rotate it and we'll bring it down. And what that'll do is your hand has got the natural tension to drive it down one direction. If you keep rotating it, it'll prevent it from getting slanted in one particular direction. That's just called surfacing. There's of course very fancy ways of doing it, but this is kind of the back home mechanic way. I've done many exhaust manifolds and things doing this method. It works really well. So you just need something like a really nice thick piece of glass or piece of marble, something like that that's very flat, and you won't cause any issues. So I will get this done, and then once I get done, I will join back in and show you the results of all this, getting it prepared to reassemble. One more thing that I almost forgot was on this side, that on this area right here, there's a little lip here, and that lip goes into here. Now the problem is I can surface this out nice and flat. This is going to be more problematic. I'm going to have to work my way around this groove on the outside, trying to keep it as flat as I can, but look how it's going to be very difficult to keep this flat all the way around. But I will do my best to do that. But once it comes down to where we really need to get these leveled out at the very end, the plan is I'm going to use some valve grinding compound. I'm going to put it on the surfaces in here. Valve grinding compound is just has a little bit of sandpaper in it, or sand grit into it, that I can put on here, and then take these two halves of the case and get them lined up, and then I'll rotate it back and forth like this. And that, with the valve grinding compound, should wear down any misalignment issues. At least get it as close as I can for the sealing. I'm going to end up using probably some copper RTV and the gasket combined when I finally assemble this. And I'm also going to do a vacuum and pressure test on this bottom crankcase to ensure that there are absolutely no leaks in there, as well as over in this section, because I want to use that for the my greasing or oiling experiment for the clutch shaft area. I'm going to vacuum test this as well to make sure that I don't have any leaks. I don't want that gear lube leaking out of my case. So that pretty much does it. I will talk to you back again once I have all these pieces completed and I'm ready to reassemble. There's more coming as well. I do want to get this balanced. So I have another video that I'm going to do on getting this ready to go as well. Just need to get a little bit more balance on it than what it's set at right now. And then before final assembly, we're going to get this all put together. But once we get the jug back on and the head on, we're going to do the degree wheel and check the stock degrees of everything. And then we'll start porting and polishing and checking out the degree wheel after we have cleaned up the head. Most of this, all I'm going to do to it is level out these ports. The intake port, I may just rough it up a little bit. It is pretty smooth. We want that to be a little bit rougher than it is. Exhaust port, it looks really good right now. I'm just going to, there's a sleeve in here, and then there's the port. I'm going to match the sleeve to the port because there is a rather large ledge all the way around the exhaust. And in fact, I'm going to widen the exhaust out as well inside here so those gases can get pushed out easier. But I'm not going to raise or lower any of these ports, or not planning to very much. Because of the timing of things, I don't really think that's going to be necessary. I'm probably going to widen some of these out a tiny bit, but I don't want to change the timing of the events. So that's about it. Once I get to the compression side, I may have to shave this down, stuff like that, but that's all coming as well. We'll figure that out when we're ready for that.